All right, so this question says a rock is dropped from a bridge over a river. Which graph could represent the distance fallen in feet as a function of time? And so again, we're looking at all our graphs. We want to connect what we have learned about different types of graphs of functions so far, and apply that to this context. So this represents a situation where an object is falling. And what we've learned previously is when objects fall, that relationship between distance and time is modeled by a quadratic growth kind of a graph. And that is going to be one that is curved. So it would not be A, because those are linear relationships. So it would either be C or D. Now, when we're thinking about objects falling, I know it can be tricky. You're thinking about falling, so you're thinking about something going down. However, this graph should be showing the distance fallen, and so as time progresses, we know the distance fallen should increase. And so choice C or option C is the best model in this situation, and this makes sense because the distance of falling objects is quadratic growth, as I said, and also as time increases, the distance fallen will increase. So that is what is being depicted by graph C. D can be a trick because you're thinking, oh, I'm standing on a bridge and the thing it's falling, so the distance should be going down, but that's not the case. Here we're measuring the distance fallen, so that distance should increase as time progresses. The other question that we're answering here is also we're to use a graph to determine the distance object has fallen in 3 seconds. So we know our time, 3 seconds is going to be on our x-axis. Locate that time, line that up with the distance on your y-axis, and we're seeing that again this is counting in increments of 20. So this is 20, 40, 60, 80, 100, 120. So in between 120 and 60, that's going to be 140. So what that means is, in this particular case, that the distance that the rock has fallen in 3 seconds is 140 feet.